So today we're going to look at this thing here, digital insulation tester. I showed this briefly in the mailbag not long ago, a week or so ago. What we've got here is a little charger. It does charging 18650s or whatever. These 18650s. USB-C charging cable, is it? Yep. User manual. Nice little pouch. There it is. So it's a Zoyi ZT-1000R. So this has been sent to me at no cost by Zotek / Zoyi for the purpose of review. And I did show this briefly in mailbag, just have a quick look at it to actually turn it on and stuff. So what accessories you get? Also you got the bag. We've got some little hook-on clips. So it's quite important for doing insulation resistance because you want to be hands-free. You don't want to be touching it. So that's what these clips are for. So you can clip on and keep your hands out of the way. PVC cables, a metre long or so. Standard cables. Standard tips, got the insulated sleeves on them for extra safety. Don't forget this is meant for higher voltage stuff generally. That's what these sorts of testers are meant for. Only having the very tip exposed is a good safety feature. And we've got a thermocouple here, not sure what type that is. And so you've got the battery charger thing there. Now the meter has a tilting bail, batteries in the back there. It's got rechargeable batteries, which is why you need a charger. The reason they've done that is so you don't have a charger plugged in whilst trying to use it. It's a safety feature. Because this can generate 1000 volts, you want to make sure this is isolated away from any circuitry. Even for general multimeter use as well, you can actually say the same thing. You know, you don't really have your multimeter plugged in testing circuitry whilst you've got the thing on charge. So it's a good safety feature that you have it with rechargeable batteries and you take the batteries out to charge them up. It's a bit less of a convenience in a way, taking the batteries out to charge them. But then, if it lasts a while, it's not that big of an inconvenience to take them out and refit them. You might even be able to rotate batteries around. Let's take the batteries out and actually have a look. See what's in here. That's not the right screwdriver. There you go. So you've got some 500 milliamp hour 14650s. Interesting. So 3.7 volt nominal. So it's lithium ion. 500 milliamp hours and 14500s. Most people have heard of the 18650s, so this is like the next size down. More like an AA size battery actually. I don't think you could run this off AAs. Doesn't say there. Anyway, that's how you get to the batteries. So it's quite good. It's got a threaded insert in there too, so it's actually a proper threaded insert, not just into plastic, so that's a nice design feature. Also, the fact that the tilting barrel comes off with that and it's detachable means if this were to break, you might be able to get a replacement from Zotek. I don't know if you can or not, but you may be able to. Although that said, the tilting barrel actually feels quite sturdy, feels quite strong compared to other units I've looked at in the past. It felt like it could be used fine without any issues of worrying about whether it's going to break when you try and use it. Okay, look at the manual. You can read this in your own time. I'm not going to read it myself. You can read it. If you're interested in something, pause the video and read it whilst it's paused. Specs, let's have a quick look at these. Sampling rate 2 times a second. Okay. 19,000 count. Auto power 15 minutes. Okay. It's got backlight. More specs here. This is what we really kind of care about. Plus or minus 5% on those voltages. Up to 10% plus or minus on the 1000 volt range. So it goes up to 20 gig ohm. Nice. Ranges. Electrical information. DC voltage 0.05%, that's a pretty good claim. Plus 3 counts. I'll put this on my calibrator and see what it comes out as. We'll see how we get. I'm not going to sit down and work it out whether it's actually within the spec or not. You can just figure that out yourself if you want. AC voltage 0.5%. It's typical for AC to be worse. Resistance 0.3%. Yeah, 1% there. Capacitance 5% for low value, 2% for the medium value, 5% for high value. Okay, it's typical. Frequency 0.1%. So it's like a 1 megahertz range with a resolution of 0.1 kilohertz. And information there. Okay, there's that bit. So let's actually see what features it's got. I did kind of talk about this in the mailbag, but obviously this is the mailbag, so let's start again. So I've got manual dial, so you've got DC volts, AC volts and frequency. Guess we push that button to change between the two. Yep. It mentions 2 RMS here as well, TRMS, so true RMS. Resistance and capacitance. Diode and continuity. And degrees C and Fahrenheit. Although it kind of does both, so. It looks like it doesn't remember the last mode you used either. So I've changed these ones and I didn't actually remember them. So it's not remembering the modes, which is a shame. It'd be nice if it did that. Okay, and then this side we've got 50 volts. So these are the insulation resistance tests, which is these ports. These ones are the multimeter. Looks like the standard spacings. I'm just going to confirm that in a minute. So we've got 50 volts, 100 volts, 250, 500 and 1000. Most things you wouldn't really use 50 volts or 100 volts for unless you're worried about delicate equipment. And it's not really mains power, this is other stuff. 250 volts you'd use on like 115, 120 volt systems. 500 volts you use on 240 volt systems. And 1000 volts you use on 400 volt systems. So we always have to test a higher voltage than the system's designed to work with. That we know your installation's not breaking down. You've got a test button here, so when you push that it will do a test. So that's putting out 50 volts. It even says so down there, what it's actually doing. There you go. So it actually holds it on the screen as well. That's nice. So 100 volts there. I think it's because I pushed it and let go, and it's holding, and then doesn't want to do it again after that. Is that right? Something like that. There's something called it. Anyway, so you can see the voltage coming up there. So you've got relative PI and DAR. So dielectric absorption ratio. PI, I've forgotten what that is. Obviously relative mode. So if you're doing like a resistance, relative will rule it out. Hold backlight. There's the backlight. My lighting here is quite bright, so it's kind of hiding it, but here it is. And you've got a holding as well, so you want to hold the value you can. Okay, straightforward enough. Let's check the terminal spacing. So, standard cable, 3/4 inch. Yep, plug straight in, no worries at all. Let's put this into the PDVS2 Mini by Ian Johnston. Although these are no longer made by Ian Johnston now, they're made by Rytec, who sold the rights to it. So they're made by somebody else, and they've been making some modifications to the design. But this is my one, which is one of the prototypes. 0 volts out. Try and get so you can see on screen. And we'll see this as well. Alright. Let's do 1 volt on here. Not looking bad. I'll do more extensive testing when I go to the Calibrator. This is like a quick overview just to see how it's going. 2 volts. But it's only 6 counts out there. Don't forget it was 0.05%, wasn't it? So 0.05 would be there. So I think it's in. And I was saying I wasn't going to check the specs. 3 volts is looking good. 4, good. Yeah. 7 volts is bang on. 8's bang on. 9. Oh, 1 came out. Oh, I did just make it. And 10. Yep. So that's looking pretty good actually. It's looking very accurate. So that's looking decent. The other thing we want to do is check the continuity mode. Let's get the original probes that came with it and try those, because you can get different results. And I also got my tester sitting here as well, which also was sent to me by Ian Johnson. And we'll see how it responds. Now, different probes can give different results. If you want really good continuity test results, you need to do some probes. Let's change it to continuity instead of diode. You can get an oxidation layer on these things, and they don't work very well unless you give them a bit of a scrub. So let's just try to give them a bit of a clean or something. Sometimes that can help. Yep, that's definitely better. Okay, now let's actually do this with a proper tester so we can get some meaningful measurements. So I'm going to use this thing, turn it on. So, dim and continuity tester. Okay, so 5 milliseconds, it's barely doing it. Seems a little variable, depending on timing. No, that's still not 100% reliable. "18 milliseconds looks reliable." Let's change that. So now it's missing some, going faster. Yeah. So 20 milliseconds looks consistent. My best multimeter goes faster than this. Even 20 milliseconds isn't bad. It's actually faster than my flukes. So that's okay. But if you had better test leads on it than the original ones, these coatings aren't great. This is just nickel coating, right? So they're okay for general purpose use. But you want really nice ones for quick, fast precision, then you probably want gold plated. These nickel ones are, I mean, they're fine, but you know, they could be better. If you want to have decent probes, then it's worth investing in them. So that works okay. Let's look at the diode test mode and stuff like that and see what voltages we're getting out of it. So let's actually get my fluke meter and we'll see what this is putting out in diode mode. So it's doing 1 volt in continuity mode. Diode mode is doing 3.2. Okay, 3.24. So that should do most LEDs and stuff actually. It's pretty good. So it should light up even white LEDs. So that's okay. Now, does it beep when you do a diode test? Now, some meters will beep when they get a reading below like 1 volt or something. Does it do it? No, it doesn't. So there's no beep. Which is a shame, because I actually really like that feature, because if you're doing circuit testing and you're going around probing components, you don't have to look at the meter the whole time. You can just test the diode and go beep, okay, yep, beep, yep, it's good. That beep means it's less than 1 volt drop and probably more than 200 millivolts or something like that. So it's in that range. I actually really like that feature when I have that beep. We don't have that, unfortunately. Let's look at ohms. Let's just touch the leads together. What do we get for zeroing? Again, you can see the contact resistances there jumping around. Right, again, this is the thing with basic nickel probes. So now I've got that. See, look at that, 0 ohms now. At a good spot. But when I'm somewhere else on the probes, not so good, right? So this is one of those things, if you scrape them a bit or something, maybe it'll come better. Yeah, because there's a coating on the nickel. Once you get rid of that, it behaves a lot better. So when you get a new meter, you may go, oh, these leads aren't working very well, the meter's not working well. Get the probes and give them a good clean up, you know, even if it's like a piece of paper or something like that. Give them a good scrub with that, and you'll get a lot of the coating off. And that, once you get rid of that coating, then they behave a lot better. So we've got very few things to actually check on this, which is good. We've got capacitance and resistance, which I can check on my calibrator. We've got voltage and frequency, I can check on the calibrator on AC and DC. I'm going to get my capacitance standards out and we'll just chuck them on that and see where they come out. So I've got some capacitance standards here. So I've got a 200 picofarad, a 1 nanofarad, a 20 nanofarad and a 1 microfarad standard. Let's plug the 200 in. Set it to capacitance. Plug it in, what do we get? 161. Loop it out. Plug it in again, just in case of dirty connections. 161. Okay. So that's a little bit out. Not unusual, I do tend to get that one being a bit low in meters actually. You don't tend to always read it correctly. Okay, so this is 1 nanofarad. Reading slightly high, that's fine. Next one, it says 20 nanofarad. Reading high. 1 microfarad. That's bang on. It's not too bad. So now I've got a 10 microfarad. I'll just put it onto my LCR meter. At 100 Hz it's measuring 9.7 microfarad. Let's see what this meter thinks of it. (10.4), reading high. It depends on its measurement technique. Now it could either be doing like an RC network where it's charging it up and measuring the voltage and it's working out what it is from that, or it could actually be using a frequency type system. Now an LCR meter will use a frequency because it actually runs AC through it. I don't know what this is doing. Shall we have a look, see if we can figure it out? Let's see if we can see any readings off the actual meter like this. Let's try it. Getting 2 volts DC. 450 millivolts AC showing up. So did I say 2 volts? I mean 0.2 volts. Yeah, 0.2 volts DC. So yeah, so it is using an AC type frequency here in order to work out what the capacitance is. What frequency is it actually using? .4 kilohertz. Okay, interesting. But that frequency might change with the test. So often it'll be part of like an RC system, I suppose. It forms part of an oscillator, so as the capacitance increases, it loads the circuit down more and it causes a lower frequency of the test. So that's 5.4 kilohertz free air. When you've got a capacitor across it, it could be different. So let's get another capacitor. LCR meter says 94 microfarad. And this says 98. Yep, 98. So it's a bit closer on higher capacitance. So that's slightly better. Okay, let's do one more. Let's do 1000 microfarad. 873. So 920, 919. Bit of a difference here, but still, ballpark. It's close enough. We've got lots of tests to do. It's working. It's doing something close to what I expect it to be. So we want AC volts and frequency and DC volts. So we'll do those on the calibrator, like I said, and as well as the resistance. Temperature. Let's have a look at this. We've got a thermocouple here somewhere. Now usually when you don't have a thermocouple connected, you'll see the ambient temperature. It says 21, so that's quite expected. It's cold junction temperature. It's like a reference point really. So thermocouple plugged in. So there's the actual thermocouple, and I'll touch that. There we go. So I've got dual display, centigrade and Fahrenheit at the same time, which is nice. It doesn't switch between them. It would only ever do that. Okay, next test. Let's do this part. So the PI and DAR, they both do like a longer term insulation test. Normally you do an insulation test, it's only for a matter of seconds, but when you use those it can be for like up to, I think it's maybe half an hour or something like that. You can actually do like an absorption ratio, so it's probably in the manual actually. You should read that. So let's just have a look and see what we're getting in this mode. So it's measuring gigaohms. So 50 volts, it says we're doing 54, we're actually getting 54 on the fluke, and it's measuring 10 megohm. That's what we expect. Okay, let's do 100 volts next. 100 volts there, 103, fluke says 102.4, so rounding up, yep, that's fine, and 10 megohm, as expected. 250 volts. So it's 257, 256. Slight indiscrepancy there, but it's, you know, ballpark, and 10 megohm. 500 volts. That's why I'm happy to use on a fluke, because the fluke can take it. I know I can take it. So it says 510, it's actually doing 507, and still 10 megohm. And 1000 volts. It says 1013, it says 1018 on the screen, and 10 megohm. So that looks like it's doing what it should be doing there. That's good. So I'll put back down to 50 volts. Let's make it a bit safer. Let's push this button once and it'll go into the, I think, the PI mode. Well, that says DAR there. It's interesting. It says PI DAR. There goes DAR then PI. So standard DAR and PI. Well, let's push the button. Wherever I start it. I'll just push it, don't hold it. Okay. So I'd be interested to see how long this goes on for. So it's doing 50 volts and 10 megohms. I was going to leave this running and see how long it lasts for. I'll come back once it's done. Okay, it just beeped at 1 minute. Test is still continuing, so it's completed 1 minute test. Still going. I don't know if it will stop by itself, but it beeped, so I guess it's a prompt. I don't know if you noticed this, but it says minus 54 volts. PI means polarization index. I'm actually reading the manual now, trying to find out about it. It's just that bad, I'm having to read the manual. So although the manual actually explains that PI means polarization index and DAR means dielectric absorption ratio, it doesn't actually tell you anything more than that. 5 minutes, no more beep. It doesn't actually explain what the test does. I suppose it assumes that you actually know what you're doing and you actually understand what those tests already are. If you're an electrician, you already know. Well, the test finished after 10 minutes. So it chooses 1 minute and 10 minutes. That time frame checks at 1 minute, checks at 10 minutes, and checks the ratio. And so that's looking good. Now we also got DAR. Come around here, which is apparently a 60-second test, or 30 seconds and 60 seconds. So let's do this one as well. Let's see what this one does. It's also a ratio thing, apparently. It's interesting this is negative voltage. Okay, it's 15 seconds instead of 30 seconds. Guess they're doing it over a shorter time. I think it will stop at 1 minute. I could be wrong. Okay, DI of 1. Well, the test works. The timing is interesting though. It's like, was it 15 or 16 seconds and then 1 minute? It works, it does something, so yeah. Let's check this thing on the calibrator. So here you are in my Datron calibrator. So we shall do DC volts first, because that's nice and easy to do it. I'll put it on. We'll do 100 microvolts. See if we can see that. I don't think it will, because it's only got that digit there for that. That looks like a no. 1 millivolt. Yep, 1 millivolt. It's actually looking 1 count out. Does it have that resolution to go down? It does. Okay. Yeah, 200 microvolts is reading that, so it's out by 1 count. But that's alright. Okay, 10 millivolts. Very close, 1 count out. 100 millivolts, which is a couple of counts out. 1 volt, which we did with the other unit before. As you can see, it's also still low. 5 counts down. 10 volts. Yep, that's bang on as we saw before. Now what we can also do is do negative 10 volts. Sometimes that kind of thing can throw things out. But yet that's a couple of counts out there, negative 10 volts. It's fair enough. It did allow 3 counts, so that's in spec. 100 volts. So 100 volts is 3 counts out, 4 counts. Yeah, quite 3 counts out. Let's go a bit higher. What I'm going to do here first is do that. So we're going to go down to 200 volts first. Bang on. 300, bang on. 400's good. 500, good. 600's 1 count out, right? 2 counts out, or 1 count out, 700. 800's 1 count out. It's not bad. It's doing alright. 3 counts out, 900. And 1000. It beeps. Okay, so it's 3 counts out there. I mean, the beeping is obviously a warning to say, hey, it's over range. Now, we've got this scale here as well, this bar graph. I don't know if you can see it here, but it's there. I mean, if the range can only go up to 1000 in this case, shouldn't it be up here? But it's because it's 20,000 count meter, so it's just using that scaling, I suppose. Anyway, let's now we shall do AC volts instead. So AC volts. Start the last one I can do, which is that one. 1 millivolt AC. Oh, turn it back on. There we go. So 1 millivolt showing nothing. 10 millivolts. This is at 1 kilohertz, showing us 5. So let me just change frequencies here. Let's do 100 hertz. Closer. It's not unusual for meters that struggle with these really low levels in AC. It's not surprising at all. That's really struggling with that one. Let's try 10 kilohertz. Can't see it. Okay. So 100 millivolts at 10 kilohertz. Can't see it. So it's 20 counts down at 1 kilohertz. And 100 hertz is causing it to jump around a little bit, but struggling 100 hertz. So it's jumping around. Sometimes it's right, sometimes it's not. Okay, let's do 1 volt. See if it improves with that. One volt still jumping around a lot, 100 hertz, which is surprising because 100 hertz is a frequency you'd commonly see when you're working on equipment. At least in my country, you know, countries that have 50 hertz main supply, 100 hertz is something you'd see quite a lot. Linear power supplies and stuff like that. So 1 kilohertz, it's perfectly happy with that. It's reading 35 counts high, but that being spec. Let's try going down in frequency and try and find out where it doesn't like it. So that's 500 hertz. It's really well there. 200 hertz. Not too bad. Let's just try 60 hertz. Yeah, that's okay. And 50 hertz. 50 hertz is but jumping around a little bit. Yeah, there we go, jumping around. So it's interesting that a really common mains frequency, 50 hertz, this is actually struggling with. That's actually a bit surprising. You would expect that to be more stable because this is measuring AC. Should be able to measure that. Okay, well, let's do 10 volts. See if that changes anything. See if it stabilizes. It is looking better. It is looking better. It's handling that a lot better. So let's go back to 100 hertz again. Yeah, that's looking better. Okay, 1K. So it looks like that those lower levels, it just didn't like them. So 1 kilohertz, looking alright. Nice and stable. 10 kilohertz. Can't see it, it's miles off. So let's find out what the frequency limit is. Now at 10 volts, let's see what we can go down to get a reasonable reading. So 5 kilohertz. It's always nice to know the limitations of what frequencies. So 3 kilohertz is getting closer. 2 kilohertz. Yeah, that's a fair percentage down. Not too bad. Yeah. Let's say 1.5 kilohertz is the frequency limit for AC measurement. I think that's going to be a fair thing to say. Okay, 100 volts. We'll go back in a minute and check the frequency readout on this as well. The beeping is the calibrator, not the multimeter. Should specify that too. So that's looking alright, 100 volts, 1 kilohertz. Hertz, see if this is stable. It should be. Yeah, it's looking alright. Now it's at a higher voltage. Let's do higher again. So 300 volts AC. 100 hertz, it's not looking too bad, couple of counts out. .600, still a couple of counts out. This is rated for 750, so I can't go above 750. 700 is one count out. 750, there you go. 751, that make it beep, there you go. Alright, cool. Let's go full scale 1 volt and let's change the frequency mode. So I do 100 Hz and it's measuring out by a couple of counts there. A couple of counts out on 1 kHz. A couple of counts out on 10 kHz. A couple of counts out on 100 kHz. And 1 megahertz. Can it see it there? It can't. Let's increase the voltage a bit. There we go, 1.5 volts, now I can see it. And that's measuring a couple of counts out. So the frequency actually looks reasonably good. It's always 2 counts down. That's fine. Okay, so next we want to look at resistances. So let's change over to that. So this has only got 2-wire resistance option, so that's what we're going to be doing. I should change this over actually for external. Okay, it's made that. Just change it over for 2-wire mode. So there we go, 4245. It's looking alright. Ohms. Oh, 10 counts, 13 counts out. So 1K, looking pretty good. 3 counts out, inspecting it. 10K, looking pretty good. 4 counts out. 3 counts out, yep. So 100K, 5 counts out. 1 meg. See what it settles down to. 1 meg's looking really good. Yep, it's basically bang on 1 meg. So 10 meg ohm, same deal, stabilised a little bit, but that's looking pretty good actually. 1 count out. Can I do 100 meg? No, it can't. Well, it's not in this mode. In the installation testing mode, you could do it, but you don't. I'm not going to run installation tests with this thing. I don't know if it's potentially damaging something on my calibrator. So that's that done. Well, I suppose the next thing we need to do is pull it apart and have a look and see if we can see how it's constructed, what safeties there are inside it and that sort of stuff. It's got a plasticized PVC membrane here. It's not rubber. It's plasticized PVC, or it's not TPR, which is also a good thing because those tend to deteriorate over time. Plasticized PVC will get stiffer. That's about it. So, not so bad. All we'll do is get it out.
2 hours later.
Okay, let's get the screws out of this thing. These are the self-tappers in the plastic. Yep. And that's fine because it's the casing. You don't really need to pull this apart. One thing I've noticed is that it's sitting on the dial. So if it goes face down, it's going to land on the dial, which is then pushing on the circuit board. That's potentially bad. Anyway, I'm probably just being too fussy. So there you go. Battery holder's got connections on the back. And there's what's inside. Great, let's have a close look. So here's the inside. And as expected, chips have got markings rubbed off. This one here has anyway. These ones have got markings on. So I've got the 4 jacks here. So these 2 are the output, those 2 are the input. We've got some PTCs and MOVs and stuff around here. Capacitors there. This is going to be like a boost circuit just here, which is generating high voltages. That's what the capacitors and the coils for, most likely. Be a diode there, somewhere too. There you go, there's a diode. Got a network of resistors here, all in series, because that is for the voltage, the safe working voltages of those resistors. You have to put them in series, because each one could be, you know, a couple of 100 volts or something. So you put them in series and you're definitely safe. Gives you a big element of safety. Got a spring contact there and there for the battery. A couple more resistors down there. Another PTC. MOSFET down there. It's probably doing the switching for this thing. Bolt caps. Okay, so look at these devices here and see what these are. 48751, don't recognise those. TL494 over there. So the microprocessor's got no markings on it. That is a 24C08, has a flash chip. It's probably got the firmware and calibrations in it for the processor. Means it could be an STM32 or something, I'm not sure. And an SF2613B. Don't know what that is. Probably a display driver based on its location. Obviously got a buzzer that's there. 4 MHz crystal. LED there. Oh, I think that's right, I did a torch. That's right, when you did the backlight, that came on as well as a torch. I forgot to mention that. Okay, so there's not much to say. I'm not going to take the board out. But that's what's there. So there is some protection in there. I don't really see any fusing anywhere, but then it's relying on the PTCs, I think. But yeah, okay. Don't forget that. Subscribe and click like. I'm going to say this again in case you haven't heard it before. I've said this many times before. When you're putting self-tapping screws back in, give them a turn backwards first. It will drop into the threads. Hear that cluck? Then you can screw it in. Right? That way you're not cutting new threads each time you put the screws in. It means your plastic's going to last much longer. It's a good thing to do. If you don't really care about the plastics, then sure, whack it in. But if you want it to last, see, backwards. There you go. Then go in. Just a good thing to do. So I'm going to demonstrate the LED on the top. So hold it for the backlight. There you go. So you've got like a little torch. So if you're trying to work in an area in a panel or something, maybe it will help. It's not very bright, but it might be useful for something. One thing I wish this did have is a slightly bigger pouch with pockets in it. So you had pockets for the actual accessories that come with it, and also somewhere to store the charger. Because having this ability to carry it around would be really useful. Right now, you got these two things like, well, if you need to charge your batteries up, where's your charger? I don't know, you lost it. But if it's in the bag with the unit, you're fine. So I wish that's something it actually had as a pocket to place those things. Yeah, just needs a slightly better bag. Links down below for this thing if you're interested in it. Go into Zoyi's website. I might have some commission links there. I don't know, I'll see what I'll find. If I can find links for this thing on AliExpress, for example, I'll chuck some links down there for that. Have some commission links so I get a little bit of money for the channel and help me to maintain the channel. So thanks a lot Zoyi and Zotek for sending that to me at no cost. That was brilliant. If you found it interesting, don't forget to subscribe over here. If you want to become a Patreon supporter, there's a link just over there. You can become a Patreon supporter. A couple of dollars a month, all it takes, and you get early access to my videos and extra things like manuals and things like that. Software if I can, that kind of thing. So, catch you later.